Today, like I said, well, we're going to be talking about data collection and sampling in quantitative research. And I remain Michael Awule, Principal Research Fellow in the African Institute for Science Policy and Innovation. And that's that. So quantitative research mainly, it investigates phenomena using numerical data. It's mainly about numerical data. Quantitative, that's the word. You can quantify it. You know the number. It's about the number. If you want to know the number, how many people were involved? How many people died in car crash? How many people were able to use the tool? In terms of the quantity, the count, the frequency. This is what the quantitative research is all about. And another one is it objectively measures variable relationships and test hypotheses. There are a number of variables. We have dependent variables, independent variables, proxy variables, dummy variables, and all of that. This essence is to be able to look at the interaction between any given variables. We want to know the interaction between the variables. Is there any cause and effect? Which variable affects the other? Or what are the variables that affect maybe the dependent variable and all of that? And it's also handy when it has to do with testing hypotheses. Because when you can set your hypothesis, and then at the end of the day, after setting your hypothesis we have defined that I think is more or less like a statement that you just put forward as you want to begin your research. A statement you put forward, it is not yet confirmed whether this statement is true or not. It's just a guess. So after putting that forward, then you then want to see, fine. After collecting your data, which is part of the things we're going to be talking about today, you want to be able to match it. What we find in the feed, does it correlate? Is it in tandem with the hypothesis we have set? Ordinarily, you set both your alternative hypothesis and your null hypothesis. So you want to put it side by side to see what has happened on the platform. That's fine. So after testing the hypothesis and then you have reached your conclusion, the next thing is to now say it also permits robust data collection, forms the foundation of accurate analysis. Quantitative analysis it's a robust data collection that forms the foundation for your data, for your analysis, in fact. And we are particular about the accuracy of your analysis. Because these are some of the things we're going to talk about. When you just have your data, it's not about just having your data and you just push it to analytical tool and you're analyzing. No, there are a number of things you have to check to ensure that you have done the due diligence in terms of quality assurance. Because if you don't do due diligence in quality assurance, then your output will definitely be erroneous. And we want to be able to guard against that. That is why we're going to be talking about. Because at the end of the day, you want your output, your conclusion, your summary to inform evidence-based policy suggestions, to the relevant stakeholders. So the outlines we have today, it's about, we're going to talk about types of data. We're going to look at research instruments. We are going to look at data collection methods. We have mentioned a few of these the last time that we met on qualitative analysis. And then the other one is sampling in quantitative technique. We want to see that. So this is the assignment I've been given to discuss with you. All other lecturers, my other professors, my seniors will still be taking you thereafter on a number of other aspects that are also germane to quantitative research. So quantitative research, let's look at this overview. It's quantified variables for statistical analysis. Like I said, quantity, you want to be able to put it. How many handful? How many bowls? How many measures of rice? How many, what is the counts of the people that are involved? What is your sample size? You can't have 3.5 people. It has to be discrete. And it also aims for objective results. It relies heavily on numerical data, like I've said, to establish cause and effect relationship and to predict outcomes. Cause and effect has to do with the relationship between your dependent variable and independent variables and all of that, your dependent variable and all other variables, not just independent, because there are some other variables that are proxy variables, that are dummy variables, especially when you get into regression analysis. My own presentation may not take you to that aspect of using statistical analysis, of using tools in statistical analysis. There are people also that will take you through all of that, but I'm going to mention a few things that you are supposed to do when you get there. So types of data now. Let us look at types of data, because as you go for your fieldwork, as you do your quantitative research, it is important for you to familiarize yourself with types of data that we have. It is not just designing your questionnaire. You must know the measure by which the right measure to put in place to be able to know how to capture your data from your respondents. So this is what this is telling us. If you look at this, we have the nominal here, which is a level of measurement. The description is this: categories with no inherent order. A nominal variable doesn't have any order in terms of there is none out of that is greater than the other. Take, for example, gender. If you want to capture the gender of your respondents, male or female, male is not greater than female, whether you are a male or you are a female, or whether you belong to a Christian circle, or you are a Muslim, or you are a pagan. There is none that is greater than the other. When they're on the same level, they're on the same pedestal, they're on the same, they have the same rating. Yeah, if I may use that word. Because when there is 0 rating, it means there is no rating at all. So that is called nominal variables, or nominal variable. And there are a number of statistics you can use. Example is what we have here. What frequencies, you can do frequency, mode, and chi-square with that, and a number of other ones. And then, but the ordinal, just as the name implies, it has a particular order. It has a logical order, but on equal intervals. A logical order in terms of when you are asking for the qualification, for example, now, the qualification of your respondents. People with PhDs, ordinarily, that's why you are here. The people with PhDs are higher than those with MSc in terms of degree that they are holding. And people with MSc are also higher than BSc. People with BSc are higher than OND. People with OND are higher than the O-level, that's the kind of a thing. So that's a rating. So if you attach 6, for example, 6 to PhD, then the next one you can attach 5, you can map 5 to MSc, and then 4 to BSc, 3 to OND, 2 to, to secondary school, SSC, and then 1 to primary school, and 0 to no education at all. So that's that. In that kind of a situation, we call that ordinal measure. Because you need to understand all of this, because by the time you get to your statistical analytical tools, like SPSS, Theta, and all of that, if you don't have this understanding, it will be difficult for you to know what to pick when you get to that environment. It will be difficult for you to know what measure to indicate for your package to be able to understand the variable you are introducing. So then the next one is interval and ratio. Interval is about other categories with equal intervals, but no true 0. An example is temperature, which can be measured in Celsius or Fahrenheit. Okay, so that's fine. And what that means is, if you look at this, but no true 0, it means that when you have a 0 temperature, that does not mean that that individual does not have temperature. That's what it means. But no true 0. The 0 in the temperature does not indicate that your respondent does not have temperature. No. That is just the value on the scale. Because ordinarily, we can have -20 for temperature. We can have negative, that is also temperature. So that is what that is saying. And then you can use, there are some statistics that are permitted to be used there. You can use mean, standard deviation. Ordinarily, when you use mean, the corresponding thing that you're expected to use the standard deviation. You can't do mean alone without the standard deviation. If you do mean alone for me as a supervisor without corresponding standard deviation, you have not done anything, because mean is not enough. We need to see the spread. We need to see the spread of that data as you use your mean, then correlation and t-test. Then ratio. Ratio is interval with a meaningful 0. This one, the 0 here is meaningful. It is unlike the interval, which the 0 does not have any meaning. Here, if a weight If the weight of an individual is 0, it means that weight is 0. If the height is 0, it means the height is 0. If the age is 0, it means that person has not spent a day on the surface of the earth. That's what it means, and a few other ones. So all statistical operations are possible with this. So it is important for you to be, to be equipped with some of these. Okay. All right. So the other one is research instruments. We want to look at research instruments. What are the available research instruments? And I think I have two categories. I have the survey-based and observational instruments, and also have another category, physiological and system-based instruments. But let's start with survey-based and observational instruments. The structured questionnaire, for example, will collect standardized responses. And when it's collecting standardized responses, it can be, within that questionnaire, you can have both ordinal, interval, and ratio variables there. When I say variables, I mean indicators. You can have all of them there. And an example of this is, how often do you use mobile banking? Then you have measures like, I use it daily, I use it weekly, I use it never. And if you look at this, what would you say? How will you categorize this example? This is over to you now. What type of data does this example belong to? If I use it daily, if I use it weekly, or I never used it. If you have this kind of measure, and we have discussed types of data now. So which one do you think this is talking about? Which one covers this? So omit and speak. Class participation is part of our CEO, so you have to be on your toes. Do you have a witness to respond to that?
Hello, sir. I think it's ratio, sir.
Ratio. Okay. Why do you think so?
Because you say never. If it's never a 0. And then others daily, twice, thrice, and so on and so forth. So you can count, and the 0 is never is 0.
It's no 0 here, my brother, because you can represent daily with 3, you can represent weekly with 2, you can represent never with 1.
Okay.
So the 0 thing does not apply here.
I think
Okay,
it's
sir.
Yes, who is speaking? Tell me your name and your department so that we can clear that.
Oh, you're coming from civil engineering.
My name is.
The lady first.
Okay.
Okay, thank you, sir. My name is Aderofi Ajayi, Architecture Department.
Okay.
I think it's ordinal.
Oh, you think?
I think it's ordinal.
Or you want to say categorically that it's ordinal? Okay, tell us your reason why you think it's ordinal.
Well, yes, because I think that each one of them has a higher frequency than the other. I think they are in a particular order, and one is greater than the other. That's why.
Okay, who else? Who else has another? Yes, the man now, please. Can you speak?
Okay, sir. Oh, you're coming from civil engineering. I think it's nominal because it talks about the frequency of usage. How often is the network is being used? So I'm thinking that should be nominal because it asks about the frequency of usage of these networks.
Thank you for the attempts. Thank you for the attempts. If you look at it very closely, you agree with me that it's indeed nominal. It's indeed nominal because whether you use it daily, use it weekly, it does not make you the best person. Because at the end of the day, when we compute everything together, what we are going to compute here is to look at the mean of the usage. To look at the mean of the usage.
So ordinarily, it depends on the context. In the first instance, I will go with nominal, so we can say this is nominal. And looking at it again, depending on the context, you can also say that this is also another example of ordinal. So either of the two, but it is more of nominal than ordinal in this context. So there is no confusion and there is no argument about this.
Go to the next one. The next one here is another Likert, is a form. This also is more or less like Likert type scale in a way, with about 3 type Likert type scale. You know, the other one here is the Likert type specifically measures attitudes, perceptions, opinions, and all of that. And the type of measure we have here is both ordinal and interval. And it can be used in psychology, education, human resource survey, and all of that. So I feel confident using technology. Has been graded from 1 to represent strongly agree, up to 5 to represent, 1 to represent strongly disagree, and 5 to represent strongly agree. You know, we still have 2, we have 3, we have 4 in between. This is just like a range. 2 will be something be like disagree. 3 will be like something like neutral. 4 will be like agree. Then 5 is strongly agree in this space. So if you look at this very closely again, what answer would you give? What do you think this category is in terms of the types of data? Yeah. At least I've given us the clue. Oh yeah, who is speaking?
Hello, sir. This is Bolaji Shegiri.
Okay.
I think is the type of data is interval.
Okay. All right. Who else has a contrary opinion? It is ordered. It's in a particular order. It has a grade. This is ordinal. Because strongly agree is stronger than strongly agree, because by the time you compute the mean of this, for example, 5 is greater than 1. So it means 5 is the Oga, is higher than 4, will be higher than 3, will be higher than 2, will be higher than 1. Okay, if you look at it in that perspective, I think it's better. Do you get? Because strongly disagree, it's 1 here. Disagree is 2. At the end of the day, you are going to compute the mean for this. So the higher the mean, the better. So this is in a particular order. This scale is in a particular order, which means it is ordinal. So this is ordinal. This is ordinal. This is ordinal. So another one is semantic differential scale. This assesses attitudes using bipolar adjectives. You know, example is where we are talking about branding. You want to look at branding or user experience. You want to measure the experience of users on a particular thing, whether it is the use of that tool is effective or ineffective. You know, there's a range. That kind of a range. It's this kind of a range that we have here. It's referred to as interval. It's interval. And then the other one here is standardized test to evaluate knowledge or skills. In an example where I use this is within the educational sector. You want to do like cognitive testing, maybe IQ test. Then you now have 10 multiple choice questions on algebra, and maybe you want to see the fastest. So this kind of a scale, it's ratio. Other ones is observational checklist, systematic record, observable behaviors. Maybe you are performing experiments in the laboratory, and then you want to examine behaviors, you know, or not just in the laboratory anyway. This is not laboratory test. You are observing on the field, and you want to examine the behavior of the people regarding a particular thing. So in an example where we use this is maybe classroom research. You are observing your students, the way they are responding, just like we are doing now, the way you are responding to my queries, my questions, you know. And you can also put a question like, did the teacher greet students at the start? The kind of example you see here, it's a yes or no, which is dichotomous in nature. Or you may even put a question that will say whether true or false, rather than yes or no. It's also dichotomous, true or false. All of that, that particular one does not represent anything other than what? If you answer yes or you answer no, if I say, if I push this question to you, and any, you know, like the 20-some people that we have on board now respond to me, If I say, do you know my name? Some of you say yes, some of you say no. That does not mean that you are the people that say yes, they are better than the people that say no. No. So that they are on the same pedestal, they're on the same level, and that is referred to as a nominal. That's the nominal variable, nominal measure. Just like we have for rating scale here as well. This is another rating scale. Quantify subjective judgments numerically. You are carrying out your customer service evaluation or performance evaluation, and you have given a set of questions, and you are using this rating. I'm sure you have done this before, maybe whether online when you are completing some forms, or physically when you are completing some forms. You must have seen rating when they ask you to rate from 1 to 10. In fact, when you go to the hospital, they will ask you, rate from 1 to 10 or from 1 to 7, the severity of that pain. They might ask you, how from 1 to 7, how is it paining you? Don't pain me, girl. This is 10. I'll say 10. Okay. Compared to last week when you came and we gave you drugs, they're asking you again. Compared to that other time, what can you say on a scale of 1 to 10? At that time it was 10, but now it's now 2. That way, in a way, you are telling them that, it's much better now. So in that kind of a thing, if you look at this now, we're talking about severity of that pain. The lower, the better. But if we are talking about the quality of food, the higher, the better. So that means there is an order, there is a particular order, whether it is a ascending order or descending order, there is a particular order. So in that kind of a thing, what is the type of data that you think this wall is talking about when you rate the quality of a service? Is that ordinal or interval? Unmute and speak.
Good morning, sir.
Good morning.
This is Moses speaking, sir. Moses Julius. I think it's ordinal, sir.
Fantastic. That is ordinal. Then the next one too on demographic form is also ordinal. It's no, this is not okay. Wait, this is not, the next one on demographic, is this ordinal or nominal? I want to gather background information. I want to know your age. I want to know your gender.
Hello,
morning,
sir.
sir.
Good morning, sir.
Okay.
Good morning.
This is Dr. Adedoja from Mechanica. Demographic is nominal.
Fantastic. So this is nominal, whether you are male or female, one is not greater than the other. So that is fine. Let's move. I will just mention 1 or 2 here and then we'll just move. Another one is psychometric inventory. When you want to assess personality traits or mental health and all of that, and you have an example like, I get anxious in social situations. This is a question, and you want the respondents to pick on that scale. Is either you want to, on a scale of agree to disagree scale. This is a scale. So what would you say about this? Would you say this is ordinal or interval? This is also a scale. This is ordinal in another way. Okay, that's fine. Let's move on. Data collection methods. We have the survey, we have the experiments, and we have the observational, and then we have the secondary data. There are other methods that are available as well, but these are the 4 major ways by which you can collect your data. You can gather data through questionnaire and interviews, like we have said and we have discussed. You can either use your SurveyMonkey, online tools, and other ones. We have Cochran, we have Kobo Collect, and a good number of other ones. You can also collect your survey physically by printing your hard copy. Print your hard copy questions, which is referred to as questionnaire, and you administer it to your respondents. So this will include key metrics on response rates, sample size, and all of that. So we're going to see a few of some of the things we need to know. And then when you design your survey as well, there are AI tools to assist you to design your survey. Gone are the days that you have to now be thinking on the normal thing that you're expected to do. Here, like I used to tell you, is to facilitate your work, not to do everything for you. So make sure you still do your work and you do your due diligence to ensure that the output that the AI is giving you is correct. Today, you can use AI to generate questions. I'm going to demonstrate that to you, maybe in a quick time, and then still ask you to check my channel if you want to get that done as well. So this will save your time when you generate your questionnaire with AI.
AI.
The normal thing that you are supposed to do, like is to go to literature and look for the questionnaire in terms of look for the variables that are relevant to you, and you can bring the variables into your AI. I'm going to be using ChatGPT to demonstrate. Bring your variables into AI and ask it to generate the likely question for what you are thinking. Say you just want to measure the level of usage of a particular tool. And you can also instruct the AI, you can ask it to use the relevant measure to generate the questionnaire. You can also decide to say that use Likert types K for me or any one of your choice. You can instruct the tool to do whatever you want it to do for you. So let me go quickly demonstrate this. Okay, so share. Where's my okay? Okay, so can you see my screen now? ChatGPT screen.
Yes, sir.
Okay, that's fine. You can just ask it to generate
Yes, sir.
Okay, I want to generate some questions relating to the use of social media among undergraduates. Let's say undergraduates. Among undergraduates. Use appropriate variables, or you can, instead of variables, you can say appropriate indicators corresponding measures. Just say generate 5 questions. So that you not waste our time. Let's see. Can you see that? It has given us how frequently do you use social media platforms per day. Then the variable indicator is frequency of social media use. Can you see that? It's telling us now that because by the time you are writing your chapter 3, you are writing your variables, you have to write your variables and measures. So while you are writing your variable, you are not going to write it in terms of questions. It's not going to come in question form like we have, like so, but it's going to come like this. So this is going to be the variable, frequency of social media use. And what is the measure? The measure is, this is what we have here. So which measure is this?
Hours.
I know he's measuring it in hours, but in relation to our type of data.
Okay, so this is nominal. Actually, it's nominal. Irrespective of the options that you choose, it shows that it is nominal, and that's fine.
And then look at this. What is your primary purpose for using social media? The indicator is what? Purpose of social media use. For academic purposes, social interaction, entertainment, news and current affairs, business or market. What do you say? What do you have to say about it? What is the type of measure here? What is the type of measure?
Nominal.
It's nominal, fantastic, excellent. Because whether you pick academic purpose or using it for entertainment, no one is greater than the other. Don't worry yourself about the numbering of the internet, of the, what do you call it, of AI. But look at the measure in itself. I'm going to ask you to rearrange this, to recompute this. You are going to see it now thereafter. Now, how often do you use social media to collaborate with academic tasks? The indicator is academic engagement through social media. So this one, what will you say about this? This is number 3. Fantastic. This is ordinal because it has a particular order. I use it always. I never use it. I use it often. This is ordinal. This is what I'm saying. Then the other one here, what is this? What type of data is this?
Ordinal.
This is also ordinal. Excellent. This is ordinal. I'm happy you are getting this. This is also ordinal. Look at this. What will you say about this? Which social media platform do you use frequently? Which of them do you use most frequently? And the measure here is what we have here, which is multiple choice. Which one is?
Nominal.
Nominal. Excellent. This is nominal. Yes, you are getting it. This is nominal. So this is what we have to say. So I'm going to ask you to put option box 6 in the use. I will just say use option boxes. That's what we're going to have. You can format everything for you. Can you see? So this you don't know what AI has come to do for you. That's why I was saying that a PhD you should be able to finish in 2 years. The 3 years is even too much now because the AI tool is there for you. And if you look at this, there is no copy and you can copy this one and paste it. There is no plagiarism in this because this question is doing it for you based on what you want, on your need. So this is allowed. This is allowed. This is ethical. Look at that. Look at that. Look at that. It has generated that for you. It has generated that for you. I can even say that I should put I'll ask you to group this together. You look at this again, group the group the ordinal. I'm going to the ordinal scales. Group the variables with ordinal scales together. You will see what we have for now. This will make you to save space. It will make you to save space while you are computing your questions. Oh, it did not do it. It didn't do what I said. Okay, let me just say it. Okay, put this on a table. Can you see how legible this thing is? Can you see how legible now? You can easily copy this one now and take it to your Microsoft Word and edit. So as it is now, it has also given you the hints of this type of scale by the side. Majority of them are ordinal, and then we have the nominals there. So if you look at this one now, you copy this one now and take it to your Microsoft Word, you are good to go. You can just copy here. You are good to go. All you need to do is the scale. You have to, remove the column for the scale because you don't need it in your questionnaire for your respondents. All you need is then the heading regarding variables and questions. You don't also need that. You just put that in your Word and you are good to go. So this is what AI can do for when it comes to the survey aspects in asking you or in assisting you to do that. You can watch more on my platform if you want to see a few other things that you can do. So let's move on. I've talked about the survey here, and the next thing I'm talking about is experiments. Manipulate data collection method is what we are discussing. You can also collect your data through experiments that you carry out in your laboratory. You can manipulate variables to determine cause and effect, like I said. An example is when you are, say, A given B. You want to do a test or clinical trials involving control experiments and all of that. Take, for example, now that you want to collect blood samples. And then you also want to collect, what do you call it now? Blood pressure. You can take the diastolic and then the systolic as well. And then at the end of the day, use that to derive another thing, which is the blood pressure. Blood pressure is about, I think, diastolic over systolic, if I'm not mistaken. So you slash it over one another, but then you can collect the parameters, the variables one by one, and then do the manipulation when you are doing your analysis. Because you already know that your blood pressure is one over the other. So, but when you have them, collect them separately. If you collect them together, it's not in your best interest, unless when you measure their blood pressure, you already have it at a go. You can leave it there, because when you do blood pressure, it can easily give you that at a go. So you can collect it together and say, okay, this is blood pressure and all of that. There are some other experiments that you also carry out in your laboratory. You can ensure that when you carry out those variables, ensure that you catch them one by one and you stop them one by one. Because by the time you want to do the manipulation, when I say manipulation, I don't really mean manipulation. What I have in mind is, by the time you want to do your analysis, maybe you want to scare a particular variable, it won't be difficult for you to scare. Maybe you want to find the reciprocal of a particular variable, it won't be difficult. Because these are some of the treats that you have to do on your variables after you have collected them. Because take, for example, you want to do regression of these variables. You have your dependent variable, you have independent variables. There are times that there will be a need for you to find a log of a particular variable. So, but if they stand alone, it will be easier for you to be able to do whatever analysis you want to do. Experiments are some of the things that you carry out in your laboratory and possibly also on the field. Because on the field as well, people that gather gather data in the cloud, say temperature, humidity, and all of that, they have equipment that they place on the field and they want to capture the data. And then another one is another way by which you collect data is through observational studies, like we have mentioned. In terms of ethnography, you want to be part of them, or you are just standing by the roadside looking at the number of vehicles that passes through a particular road. You want to know the number of Cadillac that are part of that, or you want to know the number of what do you call it? Maybe a particular color. We are interested in color blue vehicles. You want to do a count of that color. That's also part of observation, and you can gather the data through that as well. Then the other part, the fourth part, is secondary data. These are data that already exist somewhere that you just go and pick and use. You are not the one. You are not the original person that put those data there. You are not the one that went to the field to gather that data. So this is what we call secondary data. We call them existing data sets. You can get them from government databases or from research publications. You can also assess data reliability and accuracy. I'm going to be talking about this. You can gather them from even publications. You can go to the library as well and begin to look at the papers at maybe Daily Times, Guardian, and all of that. Do we still have Daily Times? Guardian and all of that. You are looking for a particular thing, and you have for about 20 years, from say 1990 up till date. You gather them, and you are sieving that particular thing out of that. So that exercise is part of secondary data. So data collections is all about the source of your data. And one of the things that is important is ensure that your source is credible. As you carry out your survey, do it right. We're going to see how to get our survey done right, how to do it well, how to do it right, how to do it correctly. We're going to see it as we go on. And then another source is through experiments, whether in your laboratory or on the field, observational study, whether by the roadside or anywhere in the hospital or anywhere or on the field. Your secondary data, you can pick from World Bank, you can pick from UNESCO, you can pick from WHO, World Health Organization. You can pick from Nigerian Bureau of Statistics, from anywhere. All of those sources are referred to as the secondary data sources. But I think in law, what we call secondary data is different from what they believe is secondary data. So for people in law, thank God you are not here, because I've gone for an exam there, for a PhD qualified exam in Faculty of Law, and they have educated us that their own, in fact, I had to go and confirm online. That was when I agreed with them that indeed your own definition of secondary data is different from our own. In fact, our own secondary data for them is primary. It's primary. So, but let us not mix it up. For us in technology, for us in EDM, for us in Aki, for us in engineering, for us in science and technology, our secondary data, in social sciences, our secondary data is what I have described. I'm just saying this so that at least by the time you see a law students and they are telling something contrary, don't think that your lecturers have taught you something different. Their own concept is different from hers. That is why, and I see the reason why they now cluster these groups so that at least you use the language that you use in your environment. So for data collection, I think we mentioned some of these during the time we were talking about the qualitative research. So, okay, let me give you space to ask one or two questions on that part, if there is any. If there is any. Okay, in the absence of none, this one is okay. Somebody.
I want to ask a question. I saw that you said in the survey we have both questionnaire and an interview.
Yes.
So, and we also looked at in qualitative last week. We saw that it was basically interview. So I don't know, how can I structure the interview in this quantitative method?
Please, fantastic. That's a good one. Yes. One of the reasons why we also allow you to do what do we call it now? Do interview as well, and even observation is, and that's what I do as a person. I ensure that whenever I want to do any research, I get myself involved so that I can also observe when I can also be on the field, such that by the time I'm reporting all the things I observed on the field, I may not necessarily officially note them down, but I'm noting them down because I want to use it in my reports. Not necessarily to put the figures, to count the observation, to count the figures. No, because that's not my primary purpose. But my primary purpose is to see that even the elderly ones too, the old ones too, are also participating in the culture kind of a thing, in terms of they don't like to eat with strangers. That's just an example. When you observe that you are going to the field, for example, to use your questionnaire to collect data, and you observe that, and your target has to do with youths. So your report majorly is about youth, but you can also add that you also notice and observed that even the older ones were also participating in the attitude of the youths. That's one of the reasons why you can also involve observation and a few other things. Does that satisfy your curiosity?
Yes, sir.
You don't have to definitely put a figure for what you have observed. No. But putting a figure, it's possible for you to quantify. You can also quantify your observations. You can also quantify your interviews. But you do that majorly when you are bringing in your mixed method. That is when you want to use what you have observed and when you have in the interview you have covered. When you quantify it, that is when you are trying to bring the mixed theory, the mixed method. But in this space, just let that be an add-on for you. If you are specifically about quantitative, let it just be an add-on to equip you, to assist you while reporting. You get that?
So I wanted to ask. I want to say, if can't the interview be like an open-ended question in the questionnaire?
Oh, that is allowed. That is done. You make it open-ended, and at the end of the day, when you want to analyze that, you can put it together. In fact, you have to recategorize it when you are analyzing your open-ended in your questionnaire. You won't put all the text that they have put in the open-ended. It's not all the text. In a way, you must have also do what we kind of a thematic analysis. When that person is talking about technology, you can say technological infrastructure. When that person is talking about maybe finance, you say finance and categorize that finance. So that is also possible. And I think it's even the best bet when you want to quantify it in your quantitative. So you have open-ended questions but most of the time, I don't encourage your questionnaire to have too many of open-ended, because it will not, your respondents will run away from it. Even me too, if you give me questions that I have to be thinking before I write it down, it's more laborious. But then, if you cannot avoid doing that, include one or two. So that's allowed as well. Thank you. So the other one is experimental data. So please, like I said, this is what you do in your laboratory. Maybe you want to do your control experiments, or maybe on the field, you want to assess the cause and effect that we have mentioned. And it is also useful when you want to look at your causal relationships under controlled settings. Control has to do with when you have two groups of people you want to carry out experiments on. Maybe you want to test drug trial, for example, on some participants. You have administered a particular drug to 1,500 people, and the remaining 1,500 people, you do not administer drug on them. And you capture your data from those that you administer drugs on. You also capture your data on those that do not have drugs, that do not use the drugs. So at the end of the day, you will now want to see, maybe you want to check their weight, or you want to check the level of a particular thing in their blood system. You want to see maybe the particular rating, that one of them is the control, while the other one is the trial. The control are those ones that you do not administer your drugs, if I may use that, your drugs for, and the other one are those, the control are those that you have used, that you did not use the drugs on. So those are the different types of experiments you can gather. And what the essence of doing this is to be able to do what? To also gather data. And this is called experimental data. You are involved. It can be that you are looking at what your microscope is giving you in the laboratory. Maybe you want to, I don't know, I'm not a core scientist person. I'm a scientist actually, but I'm a computing person. I do not do this kind of experiment, these biological experiments in the laboratory, so I wouldn't know. So if you are the type that will be involved in laboratory experiments in terms of bringing out different things, you want to look at the reaction of enzyme on a particular thing, this is also a form of experimental data. This is what we call experimental data. And then it has its own strengths and weaknesses. It has high internal validity, and artificial settings limits generalizability. Generalizability means you cannot all the time generalize for use in another client. Take, for example, now that you have carried out your experiments in a particular place, there are a number of things that may affect that. If you are carrying it out in a laboratory, the temperature may affect it, the humidity of the environment may affect it, and every other thing. That's why experimental data some of the time may be limited in terms of generalizability. Another one is participants' observation. We are used to this very well. You go out with your questionnaire to look at this one. This one is saying immersive observations in real life settings. When we say immersive, what out of the theories I talked about is this talking about? Immersive observation. Immersive observation. That is when the researcher is there. You are participating there. Then you use this under cultural practices and social phenomenon. Example is studying organizational culture through daily interactions. Organizational culture through daily interactions. You want to go to an organization like you are currently as a kind of a farm level data collection. Farm level, you go to the farm and you collect data from them. That's like you getting involved in the questionnaire. Farm level organization usually very difficult because some of the time they don't want to divulge their information, but then you don't have a choice if this is what you really want to do. Another one is questionnaire. We have talked about this very well. This is part of your survey. The questionnaire will assist you to gather your survey, to collect your data, and then we have talked about the measures to measure attitudes, behaviors across populations. And of course, it's not just, you are not going to deal with your entire population. You are going to deal with samples, which is what we're going to be talking about thereafter now. An example of this is customer satisfaction using 7-point Likert scale for over about 1,000 respondents. It's also at its strengths and weaknesses. Most of the time, we used to say and believe that larger data sets are encouraged when it has to do with quantitative research. Like for our qualitative, we were saying that 15, 20 people may be sufficient. By the time you gather like 20, you may have reached saturation. But for questionnaire, for quantitative research, you need sizable numbers, and we're going to be looking at how to do that almost about now, how to look for our sample from our population. But before then, let us look at this. Comparing data collection, this is what I was saying. Qualitative methods, you can use focus group discussion, like I said, interviews and participation majorly. And then our quantitative methods, you can use your experimental data, questionnaires. You can also do observations. As you are doing your observation, you are recording your observation. You are not just observing and just leave it. You can also record your observations, in your quantitative, like standing, like the example I gave, like somebody standing by the roadside and counting. As you are counting, you are noting it down. So then the mixed method, you combine the two efforts in both qualitative and quantitative. You must be ready. When you want to use this mixed method, your output will be more reliable. People will enjoy this. They will applaud your work if you do mixed method. But then it's a bit more laborious. It's a bit more laborious and more time consuming. So if you are ready and you are set for this, it's good. It's good that you go with this, and because your work will go far and many people will applaud it more. But then you have to ensure that you do both analysis, both your quantitative analysis separately using the tools, and both your qualitative analysis separately also using the tools, and then you do your reporting. So choosing the right method, you have to consider your research goals. Where am I going? It's not that, let me use mixed method. It's not that, let me just use qualitative. Oh, I think I like, it is not about your likeness. It is about what you want to achieve. It is not about you. It is about your research. It's about what your research has set to achieve. And then what are the resources that are available for your use? If you don't have enough funding, you don't have enough time, and you want to do mixed research, you have to think twice. Then your target population, you have to check whether you know the target population, whether the sample is readily available, they are readily accessible, and all of that. And at the same time, you have to look at triangulation, use multiple methods to confirm your results, especially because of the validity, to be able to say that, okay, I've conducted this research and I think I am good to go. I can beat my chest that I have done it well. Then ethics, we have talked about this very well. That's what we call informed consent. Your respondents must be informed about what you want to collect from them, the data you want to collect from them, the purpose of the research, what you want to use it for, and all of that. And then you must ensure their privacy and confidentiality. All of these has to be in place. Now, the last part is the understanding sample size. Let's talk about the fundamentals. Sample size, like I said, like we have also discussed previously in our former class, it's like a subset of the whole population. Why do you need to pick a subset of the whole population? Because of the resources, because some of the time your population, it is impossible to go through all your population. Because if your population, for example, is the whole of Osun State, how can you reach all the buildings? You want to access the buildings in Osun State, for example. You cannot count, or you cannot go to all the streets. You cannot go to all the cities in the state to begin to count or to look at the structure or the structural framework of the building. If you are in EDM, you know what I'm talking about. That would be impossible. So that is why it is important for you to cut out a sample from the population, and then you can use that to generalize for that particular location or for that particular region. So minimum respondents needed for valid results. At least minimum respondents is what we call sample. Although you are trading off large samples, because large samples will usually improve your accuracy. But then this is at a cost. It's usually at a cost. So the factors you have to note is your population size. What is your population size? This is your population size that will be a determinant also for your sample size. But then there are standards for that measure. There are standards. We have a number of standards in terms of if I have this size of population, what is the corresponding sample size that I would go for? There are measures for that. There are standards for that. And also, if we have population that is not known, how do you go about that? We're going to see all of that, how to get that calculated. But then you also have to note and mark out your margin of error. What error do I want to allow? Do I want to allow, because of the nature of my research, I just want to allow only 1%. Oh, maybe me, I can extend to 5%. Yes. So you have to decide that. And then your confidence level are part of the things that you have to consider and you have to determine. And all of this, whatever you have agreed on or whatever you have zeroed in on that you want to use must be documented in your research methods. So that whoever wants to peruse your work would see that, oh, this fellow has used this fellow has used that. In terms of he has used 5% error, or he has used the confidence level of 95% and all of that. So they can then know how to benchmark your output. They can know how to benchmark your result. Okay. So an example here of confidence level is likelihood results reflect true population. He said that they have used 95% here. He's saying 95% means 19 out of 20 times. For me, I prefer to say that out of 100, 95% means 95 people out of 100. Or if you have used 1,000 respondents, it means the 95% means, what is the 95% of 1,000? That's about 950, is that not? It means, yes, it means if you now have 950 out of 1,000, you are satisfied. This is the provision the 95% of confidence interval is saying. Your margin of error could be, most of the time, would usually range between 0 to 5%. 0 to 5%. Although some extend to 10% depending on that type of research you are carrying out. So sample size. Power analysis determines sample size. And this is critical. Determining the right sample size is critical for statistical power. And then key factors include population size, like I've said, and desired confidence level and acceptable margin of error. So you determine sample size for effect detection, especially people that are talking about effect. You want to look at the effect of using a drug or effect of taking a particular diet, exactly, or effect of using a particular tool, maybe digital tool. People that are using digital tool to facilitate their work, like I've introduced us to AI, or I've also reiterated the use of AI for your thesis. People that use AI for thesis, internet to facilitate their thesis writing or their thesis, putting their thesis together, and those that do not use, you want to look at the effect. So this is what this is saying, and then we have some formula that we can use to dictate or to select our samples. Cochran is very major when it has to do with unknown population. It can also handle known population as well. It also has a formula for that. And then you can also use factors. Factors, when you are considering factors, some factors as well. When you consider your population size, you have to consider your population size and then the confidence interval that you have provided or allowed, like your error margin, as I've also reiterated. I'm going to show us this example. This is a sample size formula, which is also a general formula. You can use this one for known population if you know your N population size. If your N is 500, you plug in your N here, you can get your unknown sample size from here. This is for a known population when you know your N. If your sample size is 500, plug in your 500 into this. Your small z is your z-score, which is relative to the error margin. Because there is a table, there is usually a table for z-score, which you normally have, like our 4-figure table. In the 4-figure table, there is a place where you look for z-score. But today you don't have to be looking for that table again because these formulas are there everywhere on the internet. You can say what is the corresponding z-score for 95% confidence interval. It will generate it for you. And that one usually, I know it's often, is about 1.96 or so. We are going to see that we move on. You can also, for error level of say 10%, the corresponding z-score is also available. So you can plug in your z-score here depending on your margin error, and then that you have allowed, and your confidence level that you have allowed. You can plug that in here with your N, with your sample N, with your population size to get your N. That is not hard at all. And if you look at this, looking at Cochran formula for large infinite populations, for the populations that are not known, for known population, there are some situations whereby you don't have the record of the population. And then all you can do at that point is to just use this formula to save your head from questions. And at the end of the day, you can then calculate it. When you do the calculation will give you 384. 384 respondents. And how do you go about that? Your required sample size is the n that you do not know. The Z-score from your confidence interval that you have picked, which is your 95%, say, will be 1.96. But if you decide to use your confidence interval to be like 90%, then you look for the corresponding Z-score of 90%, which will give you another value other than 1.96. But in this case, we're using 95% confidence interval with a corresponding value of 1.96. These are standard metrics, and your estimated proportion of the population, you can use your P, which is your P, to be like 0.5. Then your margin error is 0.0. Normally, your margin error, if you use 95% confidence interval, it is the converse. What is the 100 minus 95 will give you what? 5%. That is your error level. And when you want to calculate that, you divide that 5% by 100, will give you 0.05. That is why some of the time, when we're looking at the significance, we want to see which one is less than 0.05. So anyone that is less than 0.05 shows that it is significant. This is where we come about all of that. Anyone that is greater than 0.05 means that it is not significant. Don't worry, this will be clearer by the time you are doing the analysis, the real analysis. When you get to that, the real analysis, you will then say, oh, okay, this is what Dr. Wule was saying. So this is that here. So when you now subject those values into that equation, you are going to get, at the end of the day, it's going to boil down to 384.16. So you can then approximate that to 385 respondents for an unknown population. In a situation whereby you don't know the number of the population, the respondent that you must cover is 385. Okay, so let's look at practical applications of some of these examples. You can use it in market research, like we have said. You can use it in clinical trials. You can use it in customer satisfaction. And these are some of the likely sample size that you can draw from. Customer satisfaction would want to see that you have a bigger responses or feedback from your respondents. When you're talking about customer satisfaction, MTN wants to check if you are satisfied with the quality of their service. They can't just ask 385 persons. No. Out of about almost 40 million from their respondents, So that range has to be between 1,068 and 100,000 customers before you can have things that are meaningful, responses that are meaningful and that you can capitalize on, that will be more reliable. The political polling, you want to see, is it Trump that will enter? Is it Buhari or Tinubu and all of that? And you are talking about the whole population in Nigeria. And you want to do a poll. You can't just do a poll to 385 people alone. It is better you do for at least a minimum of between 1,000 to 1,500. Even for me, this is still even low. Maybe when you are talking about governorship election alone, this may be relevant. Or maybe the senatorial election or local government, this may be fine. You have to look at the population yourself and look at what is likely to be reasonable. And then academic research, there are a number of other approaches that can be used. Sampling techniques, I think we have discussed this in qualitative. I've just rushed through them as I'm trying to round off. Simple random sampling, we have talked about that. Each population element has an equal chance of selection. All of these crowds, they have equal chances of being selected as part of your research. That's just simple random sampling. All of them, as you look at this crowd, they have equal chances of being selected. And then we have stratified sampling, where you divide the population into subgroups. and then sample from each of that population. This method will ensure representation from all segments, so that it won't be that there are some particular sect that you did not capture. You know, we also have cluster sampling, where you divide the population into clusters and then you randomly pick from the clusters. The other one is systematic sampling, which is select from every ninth element from a list. Like you are closing your eyes and you are counting 1, 2, 3, 4, 5. You pick the ninth. You count another 1, 2, 3, 4, 5, 6, 7, 8, 9. You also pick another one, and things like that. So this is a very brief summary of the sampling technique. You know, we have talked about extensively on this in our qualitative class. We also have what we call non-probability sampling techniques, non-probability sampling. Convenience sampling, which we have also talked about, is talking about when you select participants who are readily available to you. You are not looking for, you don't want to go too far. These ones are available here, let me use them. That is convenience sampling, and it is categorized as non-probability sampling. We have the quota sampling, where you select participants to match specific population proportion to ensure representation of key characteristics. You already have some characteristics, maybe people that exhibit this kind of characteristics. Maybe guys that talk, maybe ladies that talk too much and things like that. That, every time that you see people talking, gathering together, that's the person that you see talking. I'm just using that as an example. It can be other characteristics anyway. So, and then snowballing is about somebody referring you to the next. You have selected the participant, and the participant is saying, this is where you are going to get the next person. Take, for example, you go to a widow, like I've used in the example of the qualitative. You go to a widow and you don't know. Widows will not they won't put it on their door that I'm a widow. Widow is in this house. When you go to a widow that you already know, or that they told you about, and you want to capture videos, that widow will tell you where you can get the next widow. That is snowballing. And another one is purposive sampling. When you select participants based on specific criteria, this is ideal for in-depth understanding of particular cases and all of that. You have to specify that you have used purposive sampling for your research. The later part is talking about validity and reliability of your instruments. Validity, irrespective of the instruments you have used, whether you have used questionnaire, whether you have used the survey method, which is also questionnaire, whether you have used experiments, or whether you have used secondary data, whatever sources you have used must be validated. The reliability is a concern and must be tested. So the validity measures the intents. The validity is about, have you captured or measured what you intend to measure? Are you sure that what you are measuring, it is out of what you have written down? It is not the same thing with what you have written down. And how do you go about that? That is why some of the time we'll go all out to do pilot testing. Pilot testing is more or less like a mini test before you go to the larger sample that you have selected. Take, for example, now that I want to cover 3 states in southwestern states in Nigeria. In Nigeria. Southwestern state, maybe like Oyo, Ogun, and Osun alone. What I have to do is, I have to ensure that, and if I have already decided that I want to take 200 samples in each of those states, I can decide to go about 20 in one of the states that are not selected. Just take my questionnaire and go to 20 people to sample 20 people outside the states I have selected before I go for the main test. So that if I do that, I will then come back and put it side by side with what I have in mind. And if there are some challenges, I will then fix it with that. In that questionnaire, you can then redraft the questionnaire, include some other things that you find on the field that should be there that you have not included. Or remove some questions you think that are laborious, that are difficult to retrieve on the field. So when you have done all of these, you have fine-tuned your questionnaire during the pilot test, you can then make it ready for the final test, for the main test. So these are some of the things you have to do to ensure validity and the reliability of your research. So you have to ensure consistency of your measures as well. This is very important. And one of the tools we use to check our variables or indicators is Cronbach Alpha. We can use Cronbach Alpha to test, or we can also use Cohen's kappa. Cronbach Alpha typifies in literature that your indicators, after you have computed it, must not be less than 0.7. If any of your indicator is less than 0.7, is pointing to the fact that the reliability what do I mean? The reliability is doubtful for that particular variable. So your variables, you have to compute Cronbach Alpha test for all your variables. And when you have computed that, you are expected to get a value of nothing less than 0.7. If you have more than 0.7, the better for your research. Okay, so in conclusion, we have talked about data collection, which is foundation for valid research. And one of the things that we talked about here is huge data is what you need for your quantitative research. And sampling, we have talked about some of the biases that we're likely to have if you have not done it right, and some of the things you have to put in place to ensure that your error level is determined. Your sample size, if you don't know that, you can determine that by Cochran formula and a few other things. For known population, for unknown population as well. And ethical consideration, like I have said, it is important that you also bring out ethical considerations. Take ethical considerations, ethical approval before you go all out to collect your research, to collect your data from your respondents. And then validity and reliability of your instruments, very, very important. Key takeaways. Quantitative research, like I have said, relies on systematic data collection for objective analysis. Systematic in terms of it has to be in stages. When you have ordered your instruments correctly, and then you have put them, the measures correctly, the interval, you have put it where it's supposed to be, the nominal where it's supposed to be, and you are ready to go to collect your data set. And as you go for your data set, depending on where you want to do that, whether you want to carry out your experiment in the laboratory or you want to go to the field, it has to be systematic. Then you have to choose appropriate sampling techniques so as to be able to minimize the bias in your work, so as to be able to minimize the to improve on the quality of your work. This is what this is saying. Your sampling technique is also very, very important, because if you use a technique where you cannot get that is not appropriate for a particular research, then it will tell on the quality of your work, of your output. Then you must understand the validity and reliability, like I've described, which is essential for the credibility of your findings. Then you must prioritize ethical consideration and all of that. So next steps. This is the final slide, I think. Next steps in quantitative research. You have to familiarize yourself with statistical analysis. And these are some of the statistical packages you can use. I have omitted Stata here. Stata is also very germane and important. Stata is very important and it's also easy to learn. You have to explore R. R is a very good statistical, I want to call it programming language. It's actually a programming language, but it's also a statistical tool. Then SPSS is the simplest of all. If you have not known any of this before, start with SPSS. SPSS is good. I also have on my page where I've introduced beginners to SPSS, even beginners to R. I have it on my YouTube channel. You can also avail yourself of that. Okay. So the advanced designs as well that you have to be on the lookout for. I'm sure some of our lecturers that will take you after now will also take you through some of this. You have to study quasi-experimental and longitudinal designs as well. And then mixed methods, we have described that. Learn to integrate qualitative insights with quantitative method. And then data visualization, you have to equip yourself with the skill to create compelling charts and graphs. Don't give everything to anybody outside. That's why you have this space of time on your research. It won't take you time to learn all of this. It does not take time to learn the tools, because if you learn these tools and you are doing it yourself rather than giving it out, you know what you're expecting. So that way you won't be going back and forth from your supervisor. The data I used for my PhD, even after defending in 2015, I still have it on my system. I still have it stored in the cloud. But some other people, when you ask them as a supervisor, go and collect the data set that somebody did for you. The person on getting back to him will say that we are sorry, my hard disk was formatted. I lost it to my hard drive and all of that. So to avoid all of these excuses, take 1 or 2 months to learn these tools. It will serve you good. Thank you. This is where I am going to stop the presentation today.
So if this is your first time of coming to my YouTube channel and you have not subscribed, push on the subscribe button to subscribe and the notification button as well. So as when I publish another video, you'll be one of the first to be notified of the video. Click on the subscribe button and share this with your friends or colleagues that you think they might benefit from this as well. What we do here is educational videos. Thank you.